Dear students, once again welcome to new session, session 4, part A. In this session, we are going to discuss series combination, how resistors are connected with each other. What are the various ways to connect the resistors with each other? Earlier we have discussed resistance and resistivity. Now we are going to discuss how resistors are connected to each other. And first of all, we are going to discuss, in this session, we are going to discuss how resistors are connected in series. And what is the equivalent resistance when two or more resistors are connected in series? And what are the advantages of using this series combination, or disadvantages of using series combination? Why at home, in our electrical circuits, we don't prefer the series combination, right? So where it can be used, right? So this we are going to discuss in this session. So before starting few lines, I shall like to share with you. Life is a continuous challenge and never-ending struggle. We are not made rich by what is in our pocket and banks, but we are rich by what is in our thoughts and actions. So our thought and action should be good. We are recognized in the society because of our thoughts and actions. So keeping this in mind, we are going to start our section now. This is new session. Now let's start. Dear students, now after studying resistivity and resistance, Ohm's law, how resistivity is important to us, on what factor does the resistivity of a substance depend. Now we are going to study that how if you are given two or more resistors, they can be joined together. Right? And what is the importance of joining them in different ways? What is the importance of joining different resistors in different ways, or different electrical appliances at home? Or rather, I should say, with the different electrical appliances at home. What kind of circuit do we have at home, right? And what is the advantage of this circuit which we are having at home or in our institutions, right? So first of all, here you can see that one resistor is being taken, that is R1. Now second resistor is R2, and third resistor is R3, and fourth resistor is R4, right? So now how can we join these four resistors? What are the various ways to join them, right? That electric current could be passed through each and every one, means R1, R2, R3 and R4. Now some of you must have started thinking that how to join them. The first way to join them is R1 is connected to simply R2, R2 is connected to R3, then R4. As they are standing in one line and they are holding hand of one another. So this you can see here, the first method is this one here. R1 is a resistor connected to R2, R2 is connected to R3, R4. As they are standing making a chain, making a chain. So here right of this first one is connected to left of second, then right of this second is connected to left of third one. Okay, left of third one is left hand, right? So they are standing, four people are standing holding hand of each other this way, right? So R1, R2, R3, R4. This connection, okay, is one method to join these four resistors. Now second, some of you must have made it also. The second way to join them is this one here, R1, R2, R3, R4. They are standing parallel to each other, R1, R2, R3, R4, right? So here this is the second method to join these four resistors. Now one more is there, this you can see here. So this is a third. So here more than four resistors have been taken here. So what do we call this system of joining this combination of resistors? What name is given to this combination of resistors? What name is given to this combination of resistors? So these two we are going to study here in class 10th, and these two are very, very important. Here this is the third one here. These two have been, these resistors have been connected in different ways here. So the first one here, okay. So first of all, we are going to study about this combination of resistors. What name is given to this combination of resistors? We are going to study. And how what is the advantage of this, and what are the disadvantages of this combination of resistors, right? Now we are going to study about this, right? Now we are going to discuss first combination, which is series combination. Series combination means one after another. So you can see here in this diagram, these 4 resistors have been connected one after another, R1, R2, R3, R4. So they are one after another. They are one after another. So here if we say this is one end and this is second end, the second end of this first resistor has been connected to the first end of second resistor. Now second end of R2 is connected to the first. Okay, first means we can say it is the left end. Then if we say it is right, the right has been connected to the left of fourth one. So one after another they are lying, right? So this is a series combination. So how can we define it? If 2 or more resistors are connected one after the other in such a way that same amount of electric current is passing through each resistors on applying the same potential difference, dear students, here I am going to show in this activity that how resistors are connected in series, and you will see actually what are the resistors. You are reading in books, right? And you are taught about the resistors. But I am sure that all of you must have not seen resistors. In class 10th, in all schools, in all labs, these resistors are not shown to the students, right? So here I am going to show your activity to join the resistors in series. I have got 2 resistors only.
And then again,
in place of voltmeter, I couldn't get voltmeter because of this lockdown.
Resistors
in place of voltmeter, I am using my resistors.
Some of you
so see the activity and understand and enjoy.
These resistors are not shown to the student. And now these two ends. These two ends are connected to the voltmeter. For this marker is a voltmeter, so these two are connected here across this marker. Marker we are taking it as a voltmeter. So this way, right, these 2 resistors are being connected to the voltmeter. This is a series combination of resistors, right?
Dear students, now we are going to find out the equivalent resistance when 2 or more resistors are connected in series combination. Means equivalent resistance of the resistors connected in series combination. Now, first of all, we have here you can see 3 resistors are there. R1, second is R2, and third is R3. So they have been connected here end to end. End to end in one line they have been connected, and they are connected to a battery cell. It is a cell, not a battery. It is a cell of electric potential V. So when electric potential difference V is applied across the ends of this combination R1, R2 and R3, the current which is passing through the circuit is I1, I only, not I1, it is I only. So the I current is passing through this R1, through R2 and R3. the direction of the current is this. From here, R1 to R2, R2 to R3, then it is coming to this triangle, right? And the potential difference across R1 is V1, across R2 is V2, and across R3 is V3. So this you have to write on your notebook. So now it is written here, right? So you can, but you have to practice to write on your own. Now after this, V is the total potential. Okay, potential difference applied across the R1, R2 and R3, and V1 is the potential difference across R1. So therefore, total potential difference across the combination is equal to V1, V2 and V3. You can see, right? V1, V2 and V3. Now here we use Ohm's law here because R is there. Okay, R is the resistance, R1, R2, R3 are being used. So according to Ohm's law, we know that V is equal to IR. V is equal to IR. Now Ganesh will speak out that what we can write in place of V1. What we can write in place of V1. Yes, he is saying in place of V1 we can write down IR1. IR1. Why I only? Because current in series combination is same through each resistor, right? So now let's see. Now on applying Ohm's law to all these three resistors, in place of V1 here we can write down IR1, V2 is IR2 and V3 is IR3. Now we can put these values of V1, V2 and V3 in this equation number 1. Now, and what do we get? So here by putting this, V1 is IR1, V2 is IR2 and V3 is IR3. Here RS is representing the equivalent resistance of S. S means series. R is a resistance, S means series. So together it is known as equivalent resistance of the series combination. A combination of resistors means the R1, R2, R3, and these can be R4, R5, and number of resistors can be there. Any number of resistors can be there. So RS is the equivalent resistance. This you have to remember. This is very, very important. So similarly here V is equal to IR. So we are using here IRS is equal to IR1, IR2, IR3. What is common here? Yes, Ojas, what is common here? He is saying I is common. I is common. I. So what we can do? We can take I common and using mathematics. What we can do? Using mathematics, one line I have not written. Here you can write down this is R, IR, S, equivalent resistance, and here I is common. This is I is common, and in the bracket what is left? R1. Yes, now second is R2, and then what is left? R3. Inside the bracket is R3. Right? So keep writing in the notebook. I with I cancel. So what do we get? RS is equal to R1 plus R2 plus R3. Means equivalent resistance is equal to sum of these three resistors. Now this means if R3 is 5 ohm and R2 is 4 ohm and this is R1 is 3 ohm, then RS value of this will be 5 ohm. You have to write down in notebook. 5 ohm plus 4 ohm plus 3 ohm. 5 plus 4, 9 plus 3, 12 ohm. So value of RS will be how much? 12 ohm. Value of RS will be 12 ohm. So here equivalent resistance, we can see that 12 ohm is greater than the greatest one here. Greatest is R3, 5 ohm. So equivalent resistance is greater than the greatest resistance used in the circuit. Here position doesn't matter here. R2 can be at R1, R1 can go to R3, right? Or R1 can be replaced by R2 and R2, okay, and R3 is here. So if you change the position of R1, R2 and R3, so no effect is there because they are connected in series. The current will remain same passing through each resistor. This is the important question. You should have asked this question to me, right? So this you have to remember. Position here can be changed. R1, R2, R3, their position can be changed. But the amount of current, magnitude of current passing through each resistor will remain same. Now some of you must be thinking that, sir, how to define this equivalent resistance? How to define equivalent resistance? Some of you must have got answer when I said it is 5 plus, it is 4, it is 3. So 5 plus 4 plus 3. 5 plus 4, 9 plus 3, 12. So its value is 12 ohm. So this means if we replace R1, R2 and R3, if we replace all three by a single resistor of resistance 12 ohm, then also the amount of current will remain same, right? So definition, equivalent resistance in series combination. Here we are talking about the equivalent resistance in series combination. In parallel it will be different. So in series combination, it is a single resistance which can replace any combination of resistances. Here combination of 3 resistors is there. So that the electric current I passing through the circuit remains same. Current will remain same, right? In place of 3, we can use 1 which is equal to 12 ohm, but the amount of current will remain same. Any problem here? I am sure that you must have understood. Now we are going to discuss now next topic. Now some properties of series combination. When 2 or more resistors are connected in series combination, so number 1 is this, that equivalent resistance RS. Equivalent resistance we can see here, RS is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. Right here, what do we find? That if R1 is 2 ohm, R2 is 3 ohm, and R3 is 4 ohm, then RS, equivalent resistance, will be equal to 4 plus 3 plus 2. 4 plus 3 is 7 plus 2, 9 ohm. 9 ohm. Right? So it is equal to the sum of all resistances of resistors, right? Now, electric current passing through each resistor is same. This we have seen. I is same. Electric current is same, respective of the resistance of the resistor, whether it is less or high. Electric current passing through each resistor will remain same. Total potential difference across the combination is equal to the sum of all the potential difference across each resistor. This means if V is the potential difference of the cell, that this is divided into, if 3 resistors are there, then V1 is of R1, V2 is of R2, V3 is of R3, and this is equal to the total potential difference of the circuit, potential difference across the ends of the circuit applied by the battery or cell. Now equivalent resistance, next property is equivalent resistance RS is always greater than the highest resistance used in the combination. Here if R1 is 2 ohm, R2 is 3 ohm, again I am taking same example, R3 is 4 ohm, then equivalent resistance, which is 9 ohm, equivalent resistance is 9 ohm, which is the sum of 4 plus 3 plus 2. This we can see it is greater than, highest one is here 4. It is always equivalent resistance is always greater than the highest resistance used in the circuit. It is also very important property. And when do we use the series combination? When we have to join low resistance devices, then we use series combination just to increase the total resistance, so that the current passing through each device will be less, and then circuit is not damaged. Here on Deepavali, you must have seen the fairy lights which are used. These are connected in series, right? So next point is potential difference across each resistor is directly proportional to its resistance. Means higher is the resistance, greater will be the potential difference across the resistor. Here if we take this example, here 4 ohm is the resistance, then potential difference across this will be the highest, right? because current is same. So R3 is high, R3 is high here, higher among all these, highest 4 ohm. So potential difference across the resistor is directly proportional to its resistance. These are some important properties, right? So here, low resistance devices are connected in series in electric circuit. This also you have to remember, now after this, we are going to discuss disadvantages of series combination. As every system has some advantages and disadvantages. Same way, series combination has also some disadvantages. Therefore, it is not preferred, right? So, number one is there is a single path for the flow of electric current. There is a single path for the flow of electric current. Here we can see that from this side, it is from positive terminal, electric current is starting here, conventional direction of electric current. It is going through R1, R2, R3, R4, and then it comes to negative terminal, this right, second terminal. So there is only one path. There is no any other path to come to this end. So if what happens if here R2 is broken, it fails or it's broken, it doesn't work properly, if it doesn't work, then what may happen? Because there is single path, so electric current will not reach from R1 to R3 because it is not working, it is broken. Okay, right? So no other component means R3 will not work and R4 will not work. So therefore, we do not use this series combinations. Do not use series combination, right? So, but we shall be studying here. There, because of this, but there is one advantage. Because of this, we use fuse wire, electric fuse in series in electric circuits. We shall be studying why do we connect fuse in series in electric circuits, right? Now, second point is all the components do not work properly. This is very, very important. All the components do not work properly because if R1 is electric iron, it is electric fan, and it is geyser. R3 is geyser, and R4 is a TV. Then each one here we know geyser, electric iron, geyser, right? They need high amount of electric current. They need high amount of electric current. So, but in the series combination, what happens? Each is getting same amount of current, irrespective of its requirement. So, as electric bulbs, CFL at home, we can see heaters, refrigerators, toasters, and TV have different resistances. So, they need different amount of electric current for their working. But when they are connected in series, each is getting same amount of current. So, they will not work properly. Their requirement is not fulfilled, therefore they do not work properly. Right? This is another disadvantage of using series combination. Therefore, at home, at institutions, everywhere, we prefer parallel combination. We shall be studying after this parallel combination. So, these 2 points are very, very important here, right? Now, dear students, it's a very important activity which we are going to discuss, and it has been asked in board, as it is mentioned in 2014, and in 2019 also it has been asked. The aim of the activity is to show that in series combination of resistors, same amount of current flows through each resistor, right? For this, what do we do? Let's see, R1, R2, R3, they have been connected in series, and one ammeter is also there. You can see here, as earlier you have been taught, ammeter I, its negative terminal is connected to negative of this, positive is connected to positive of this battery, right? Same with this side. So, same amount of current I is passing through R1, R2, R3, as there is a single path to flow the current. Here K is the switch. From here current can be switched on or switched off. Here connect 3 resistors are there, and V is the potential difference or potential drop across this these resistors by this battery. Now what we have to do? First we have to note down the reading. it's here given the note the reading of the ammeter after plugging, after switching, after switch on the key. Means when key is on, closed, key is closed, and current is I. Now after that we disconnect and connect it in between the resistors here. First is ammeter is here, in second case ammeter is between R1 and R2. Now then again we have to note down the amount of current passing through the ammeter. Here when we just close the key, what do we see? That the amount of current passing through this ammeter is measuring the same amount of current, right? Same amount of current. So it shows that whether ammeter is at this position, ammeter is here, or ammeter can be placed here, the amount of current will remain same. Ammeter position can be here, it is here, it can be placed here, it can be placed here, but the amount of current it shows it will remain same. From this, what do we come to know? That same amount of current flows through each resistor or element connected in series combination. This is very important activity for 3 marks. In board sometimes it is asked, right? Up to this we have discussed about the series combination. Now some practice question, some numericals we shall be discussing after this topic, after this activity. And do note down this activity in your notebook. Now dear students, after discussing series combination, now one numerical is being discussed here. So here you can see this is a diagram of resistors connected in series. Here 3 resistors, how many? 4 resistors are there. This is 0.5 ohm, 1.5 ohm, and 4 ohm, and then 6 ohm. These are the 4 resistors: R1, R2, R3, R4. And here, first of all, what do we find? Their equivalent resistance, that is RS. Here S is not mentioned here, so it is 0.5, 1.5. We can simply add, what do we get? 12 ohm. And electromotive force of battery is 6 volt. Electromotive force is when battery is not being used, in use, right? So it is O. So first of all, we have to get electric current I passing through each resistor. Each resistor means in series they are connected, so current will remain same. So V is 6, R is 12, so 1 upon 2, and what do we get? 0.5 ampere. Very simple. Now potential difference across 0.5 ohm we have to get. And V1 is equal to IR1. IR1. I is 0.5 and R1 is how much? 0.5. So also 0.5. Current is 0.5 and R is resistance is also 0.5. So what do we get here? 0.25 volt. Right. Similarly, we can find V2 potential difference across this. That will be 1.5 into 0.5. 0.5. So this way we can get a potential difference across each resistor V2, V3, and V4. It's very, very simple. Numericals based on this series combinations are very, very simple. With practice, you will overcome your problems. Right now, next question, last question of the session. This is the second numerical for practice. There are 3 resistors: R1, R2, and R3. R1, R2, and R3, and R1 is 10 ohm, R2 is 20 ohm, and R3 is 30 ohm. Right, 20, 30. First of all, we have to write them given, then to find. This will help you to get good marks in board exam. So, and potential difference across this combination is 240 volt. So here, since we know that, we are in solution we are writing since we know that. Since we know that means it is previously gained knowledge is being used. That in series combination, equivalent resistance Rs is equal to sum of all the resistances, right? So Rs is equal to 100. Rs means equivalent resistance in series. S means series, right? 10 plus 20 plus 30, we get 60 simply. And after that, you have to get current I here, electric current. It is written to find. It helps us to solve questions very easily. So since we know that I is equal to V upon R, simply we can put this value 240 upon 60, we get 4 ampere current is passing through each resistor. 4 ampere current is passing through this. Okay. So here 10 into 4, 10 into 4. So here from one question we can get second question also. We can make our own question also here. So here if we have to get the V1 I am going to solve here. V1 is how much? Current is 4 and this V1 we have to get IR. R is how much? 10. So what do we get here? 10 is equal to 10 into 4 is equal to 40 ohm. 40 volts. Sorry, 40 volt. Now in second case we have to get V2. Quickly we can do. Start doing. Some of you may be faster than me. Here current remains same 4 into here 20. It is 20. It's very interesting here. In one numerical we are going to solve 2. 4 into 2, 8. It will be how much? 80 volt. Right? Now V3. Current is same because in series combination current is same. So start. Yes. Who has done? Shivansh Purohit has done. Okay. Shivansh has done. Very good. 4 into 30 and here what do we get? 1, 2, 0 and here volt. Shivansh has done and he is saying sir sum is here 120 plus 80 200 and here plus 40 240 and the total you can see here potential difference is also 240. So this means sum of these three. Okay, sum of these three means V1 plus V2 and then V3 plus V3 here. It is equal to total potential difference. Potential difference means across each resistor V1, V2, V3 is equal to total. Okay, again you have to write, and I am not writing each and everything on the board because you have to do, right? You have to learn. So here V1 is 40, V2 is 80, and V3 is 120. By adding all these, what do we get? 240. And this V total is also here. You can see it is 240. So this way, total potential difference is equal to the sum of potential difference across each resistor. This way, this problem has been solved, and we have proved also. Thank you very much. Okay, I am sure that you must have understood. And now more and more questions will be there now after finishing the chapter for practice. Thank you. God bless you all.